Okay, our next section we're going to talk about is about quadratic functions. And before we get into solving engineering examples of those, we need to talk about just how they look in general. So most of us have seen quadratic functions before. They generally come in the form of ax squared plus bx plus c. And we see that set up as our function f of x is equal to that, or we're trying to set that equal to 0 and solve an equation. And one of the key points is if we are trying to solve an equation, we do want to get to the form of ax squared plus bx plus c equals 0 on that side so that we can work with it easily. When it comes down to working with those, we basically have three methods of dealing with them. The first one is factoring. Hopefully you've seen this before. If not, we'll have a few sample videos about how that works. And then that's one of the easiest ways to deal with answering a question. Unfortunately, it doesn't always work. But it usually makes it to where you're dealing almost exclusively with integers, which makes it easy to get the solutions once you've done the factoring and that sort of thing. But again, always work. Quadratic formula. Again, we'll talk about more in detail what that is later on. But the advantage of it being that it always works to solve the problem. However, it is required to solve the square root, which can be a little more complicated. And then the third type is by completing the square, which is just honestly a rather tedious method, but it is useful when we're trying to find the vertex, which is the maximum or minimum of our graphic. What do I mean by the maximum or minimum? Well, you can see more if we think about what the general shape of a quadratic function. And so, again, most of you have seen these before. That the general shape of a parabola of quadratic function, I believe I already gave it away, is a parabola. And so either a parabola facing up, and that's any time that that first factor, the part in front of the a squared, is greater than 0, you're going to get an upward facing parabola. And if it faces downward, anytime that a is less than 0. Other things to keep in mind are that the magnitude of a gives an idea of how skinny or fat it is. So if it's 1,000, it's going to be a much skinnier parabola. If it's 0.001, it'll be a much more spread out or fatter parabola, for lack of a more precise term. The value of c, this factor here on the end, will move it up and down. So again, if c is positive, it'll allow the parabola to move up our coordinate plane. If it's negative, it'll move down our coordinate plane. And b essentially moves it left and right. We'll see a little bit more about more in detail how that works with regards to when we're doing completing the square, how that comes into play. But it's also really what moves it left and right is kind of the ratio of b divided by a and that sort of thing. But again, b does move it left and right within our coordinate plane.